All right, welcome back to our arrow diagram exploration again. We're going to look at using arrow diagrams this time to compose functions. I feel a little bit guilty about this because it almost feels like cheating in doing this, but we're going to go ahead and do this. So to begin with, it's asking for a couple of things, either f of g of x or g of f of x, remembering that they might write this as f circle g of x, and this is g circle f of x. Okay. And so this over here means that first of all, we start with x, and then it goes into g, and the result of that then goes into f. So I'm going to start by making arrow diagrams for both of these. 3x squared minus 5 first. So if I start with the x, the first thing that happens is I square it, and then I multiply by 3, and then I am subtracting 5. These three arrows together, I'm going to kind of throw a different notation here. To these three arrows together, this is the function f. Okay? It takes these three steps to change an input into the appropriate output. So, let's see, I'm going to move that up just a little bit so that I can make sure these things, okay, those are all grouped together. I'm going to want that. That is the function f there, and then the function g, we'll do g in blue here, x, change the sign so that it's a negative x, add a 1 onto there, flip it over, and multiply by 2. Okay. And these all end up together, all right? This one takes 4 steps to make a g. Okay, so the g of x is a 4-step thing. Whatever comes in as the input, the sign gets changed. Okay, and I'm going to go ahead and erase these things because we could input anything. We don't have to input only x. This is f of, and this is g of. And so to make f of g of x, it says start with an x and put that x into the function g. Okay, well, let's make another copy of the function g. So x is going to go into the function g, and after the function g has happened, then we're going to put that into the function f. Okay, I'm going to shift all this down just a little bit. So the g has been applied first, and then the result of that goes into the f, and this set of arrows is the composition. This is f of g of x. And so to see what that looks like, we can just go one thing at a time here. Change the sign on the x, add the 1, that's a 1 minus x, flip it over, 1 over 1 minus x. This is now 2 over 1 minus x. We maybe could have shortcut our way to there. We knew that that was going to be the result of putting x into g. And then it says, put that in a set of parentheses, square it, multiply that by 3, getting a little crowded here now, 3 over 2, 3 times 2 over 1 minus x squared, and then subtract 5 from that. I'm now at the end of the thing, so this is f of g of x. Okay. Based on the last video we looked at, these things, I don't really have a clean inverse on that squared, so getting an inverse of this would be, I wouldn't be able to get a perfect inverse of this unless I restricted my domain. Okay, so there is f of g of x. Okay, that's what that looks like. Let's shrink that down a little bit. Shove that over here. If I want to do g of f of x, okay, well, my g of f of x, I start with the x. But this time, that goes into f first. So I'm going to grab my f arrows to do that, which I know are going to output at the end a 3x squared minus 5. Okay. And then I need a copy of my g arrows. And I'll attach the G arrows right on there and then start making my changes. Change the sign on everything. That'll be a 5 minus 3x squared. If I add 1 onto that, that'll be a 6 minus 3x squared. Now I have a 1 over 6 minus 3x squared. And now a 2, do that over, 2 over 6 minus 3x squared. And this is my g of f of x. So it's just sticking the arrows together and then doing what they say. And that was right there the result that I was looking for in the second problem. Okay. I can solve a number of different things this way. Obviously, I could graph something here if I knew what I know this parent function, what it looks like, so I could put, sorry, you can't see me pointing at that. I know this negative 1, 1, 0, 0, 1, 1 parent function over here, and I could follow those output arrows all the way to the end and get some points that are on the graph of this. I have mixed several, or at least 2 different parent functions together by the time that I do this, and so that whether or not I get all of the points that I really want on the graph is a little bit tricky. I might have to use some points from the reciprocal function over here as well. Okay. But that is how you do composition of functions with arrow diagrams, and hopefully you see that that's a pretty straightforward, easy thing to do. And so I'm going to stop talking.